Hey, how's it going? Today we're going to be discussing a few more complicated identities, or complex identities. These are the Pythagorean identities, the cofunction identities, and the even-odd identities. Let's start out with the Pythagorean identities. You might recall in geometry that our the Pythagorean formula is a squared plus b squared equals c squared. And that's where all these come from. These all come from right triangles, where the two sides of a right triangle is equal to the hypotenuse. And so we saw a lot of that on our unit circle, where we saw the cosine was x, the sine was y, and the radius was 1. Here, let's write that down over here. Let's make a note of that. The cosine was x, the sine was y, and then the radius was equal to 1. Additionally, it is important to think about how our unit circle is and what signs, like signs SIGNS, we're talking about for each of these functions. So I'm going to draw a quick unit circle. And let's consider what's positive in each quadrant. So in the first quadrant, the x's are positive, the y's are positive. Everything is positive in the first quadrant. But in the second quadrant, well, now the x's are negative, and so only sine is positive. But wait, we recall from the previous video that sine is just a reciprocal of secant, or cosecant. And so since sine and cosecant are reciprocals, then sine is positive and cosecant is positive. Let's look down here. Down here, well, the x's are positive, but the y's are not positive. So only cosine is positive here. And by extension, since cosine is positive, its reciprocal, secant, is also positive. What about this third thing? That has a negative x and a negative y. Well, the only way to get a positive there would be to divide them. And we recall that the division there would give us tangent and cotangent. So because these are both negative, negative over negative is positive, tangent will be positive and cotangent will be positive. So tangent is positive and cotangent is positive. So all are positive, sine and cosecant are positive, tangent and cotangent are positive, and cosine and secant are positive. Why do we need to know this? Is because whenever we use the Pythagorean identities, we're going to end up having to take the square root of these numbers that are squares, and that's going to give us some ambiguity of sign. Because when you take the square root of a square number, you don't know if you're going to, when solving, you don't know if you're going to get a positive or a negative. So let's put that into practice. We're going to start by finding the cosine and the tangent if the sine is equal to negative 1/3 and the cotangent is less than 0. These initial things, this one will help us find our value. Well, this one just helps us determine what quadrant we're in. So we have a negative sign. So a negative sign means it's going to be in one of these two quadrants. And a negative cotangent. Well, cotangent is negative in these two quadrants. So sine was negative in quadrants 3 and 4. Well, cotangent is negative in quadrants 2 and 4. So I know that this is going to be in quadrant 4. I'm just going to put that up here as a note. So first we can find the cosine by just using our first Pythagorean identity. The cosine squared of theta plus the sine squared of theta is equal to 1. Well, I'm just going to use some, well, values so I'm going to start just plugging in my values. And so I have that the cosine squared of theta, oh, and for the sake of notation, when you have a trig function squared, like cosine squared of theta, that's just the same thing as the cosine of theta squared. This is the typical notation that we'll use now. The cosine squared of theta plus the sine of theta, which is negative 1/3, squared is equal to 1. So the cosine squared of theta plus 1 over 9, because negative 1 squared is 1, 3 squared is 9, is equal to 1. I could subtract 1/9 from both sides. So 1 minus 1/9 is cosine squared of theta is going to equal 8 over 9. And so now I can solve this last step by doing the square root of both sides. Square root, and I get that the cosine of theta is equal to whatever the square root of 8 is. And so you can write down the square root of 8 and then over the square root of 9, which is going to be 3. And if you wanted to simplify the square root, you could put 2 root 2 over 3. Again, it's important to pay attention to what quadrant it is, because this could be plus or minus. Because I don't know if it's plus or minus yet, you know? So again, it's in quadrant 4, and hey, quadrant 4 has a positive cosine. So I know my answer will be the positive root 8 over 3, or positive 2 root 2 over 3. And now we can do something similar and now that we have the sine and the cosine, we can use one of our identities from the previous video to find a tangent. Let's do that really quickly. Let's refer back to our table, or to our chart. The tangent is equal to sine over cosine. So the tangent of theta is equal to the sine of theta over the cosine of theta. So the tangent of theta is equal to sine, which was negative 1/3, over the cosine, which was 2 root 2 over 3. So that's just division. So that's equal to negative 1 over 3 divided by 2 root 2 over 3, which we know fraction division is just multiplication. Negative 1 over 3 times 3 over 2 root 2. The 3's cancel out, and I get negative 1 over 2 root 2 is a tangent of theta. I could have also done this connecting the tangent to the secant, or the tangent to the cotangent to the cosecant, but that would have been a lot of extra work. Okay. Let's do this next one. Find a tangent and sine if the secant of x is equal to 6 over 5. Well, I can find the tangent from the secant using my tangent squared theta plus secant squared plus 1 is equal to secant squared theta. And let's just quickly find what quadrant it's in. I see that the sine of theta, or sine of x, is greater than 0. So sine is positive in quadrants 1 and 2. The secant is positive in quadrants 1 and 3. So that means this is going to be in quadrant 1. Okay. So let's start with the tangent. The tangent squared of x plus 1 is equal to the secant squared of x. Well, tangent squared is what I'm looking for, right? So first, secant squared is going to be 6 over 5 squared and that's going to equal the tangent squared x plus 1. Simplify that, you get 36 over 25 equals tangent squared x plus 1. I'm going to subtract 1 from both sides, minus 1, minus 1. And so 1 is just going to be 25 over 25. 36 minus 25 is going to be 11. And so I get that the tangent squared of x is equal to 11 over 25. And lastly, let's take the square root of both parts. And that's going to be, well, square root of 11 is just equal to root 11. Square root of 25 is 5. And, well, this is in quadrant 1. All are positive in quadrant 1. So I know that this is going to be positive root 11 over 5. Whew. Okay, so that finds the tangent part. Okay, let's now find the sine of x. Well, if I have the tangent and I want the sine, I'm just going to use my quotient identity, but for that I also need the cosine. Well, luckily enough, I have the secant, and I know that from my previous lesson, that secant and cosine are reciprocals. And so since secant is equal to 6 over 5, the cosine will equal 5 over 6. Since tangent is equal to sine over cosine, then I know that the tangent multiply both sides by cosine. Tangent times the cosine is equal to sine. Well, let's just plug everything in now. The tangent was root 11 over 5. The cosine is 5 over 6. I can clearly see that these 5's are going to cancel out. And so I can see that that is going to be root 11 over 6, which will equal the sine of x. Whew. Okay. These next identities are a bit friendlier. These are called the cofunction and even-odd identities. The cofunction identities refer to how sine and cosine, cofunction, are related, because I can just do this shift to transform any cosine function into a sine function, and vice versa. Same thing with tangent and cotangent, and secant and cosecant. Next, our even-odd identities refer to how if I plug in a value into an even function, I'll just get the same value as if I plugged in the positive. So if I plug in a negative, it still comes out positive, because cosine and secant are even functions. While odd functions, if I plug in a negative value, I'll get the negative result of the original. So sine, cosecant, tangent, and cotangent are all odd. So these are all odd, while these ones are even. Let's put this into practice. I can see that the sine of negative theta is equal to negative 0.97. Well, since this is a odd function, I know that the sine of negative theta is equal to negative sine of theta, So I know that then the negative sign of theta is equal to negative 0.97. And so that means the sine of theta was equal to positive 0.97. And look, I just want to find the cosine of pi over 2 minus theta. Whenever you see that pi over 2 minus theta, you know that you're going to be using a cofunction identity. So the cosine of pi over 2 minus theta is just equal to the sine of theta, which we saw was equal to 0.97. See, these ones are a lot easier, a lot easier. Next, let's look at the tangent. Tangent was also an odd function. So the tangent of negative alpha is equal to negative tangent of alpha. And so the negative tangent of alpha is equal to negative 2.36. And so the tangent of alpha is equal to 2.36. Notice how this one is in a reverse order. That does kind of mess with us. We see that alpha and that pi over 2, but it's in the reverse order of what we see in our cofunction identities. So we can reverse that order of subtraction by taking out a negative. So that's going to equal the cotangent of negative pi over 2 minus alpha. And since we know that cotangent is an odd function, that's going to equal the negative cotangent of pi over 2 minus alpha. And now we just have the regular cofunction identity for cotangent. And so that's going to equal the negative tangent of alpha, which is equal to, well, tangent of alpha is 2.36, so negative tangent of alpha would be negative 2.36. Let's do one more. And let's look at the secant of beta minus pi over 2. Well, hey, secant of beta minus pi over 2, again, that's been reversed. I wanted to see pi over 2 minus beta, not beta minus pi over 2. So I can say that this is the secant of negative beta, or negative pi over 2 minus beta. And because secant is an even function, secant's an even function, when I have a negative, I can just ignore it. When I have a negative, I can say that this is equal to the secant of pi over 2 minus beta. Well, the secant of pi over 2 minus beta is equal to the cosecant of beta. Secant of pi over 2 minus beta is equal to cosecant of beta. Cosecant of beta. Well, and then since all this equaled negative 3.62 and nothing ever changed, so this is going to be negative 3.62. Okay, so now let's just do our last part. The cosecant of negative beta. Cosecant is an odd, whoops. Hey, let me go over this. The secant of pi over 2 minus beta was equal to the cosecant of beta, which is equal to negative 3.62. And since these are all based off of, or since we're looking for the cosecant of negative beta, and the cosecant of negative beta is an odd function, cosecant is an odd function, I can see that the cosecant of negative beta is going to equal negative cosecant of beta. And since the cosecant of beta is negative 3.62, this is going to equal negative 3.62. And two negatives make a positive, so positive 3.62. And so that is our lesson for today. If you have any questions, feel free to leave a comment on this video or to ask me in person. Thanks, and have a great day.